Hello children, we will continue with subatomic particles. There are many subatomic particles, among them three are main: electron, proton and neutron. Electron is represented by small e or small e minus, minus sign written as superscript. Proton is represented by small p and neutron is represented by small n. This table shows their symbol, mass and charge. Electron is represented by small e. Its mass is 9.1 into 10 to power minus 31 kg and its charge is minus 1.6 into 10 to power minus 19 coulomb. Proton is represented by small p. Its mass is 1.67262 into 10 to power minus 27 kg and its charge is exactly the same that of electron with opposite sign, means 1.6 into 10 to power minus 19 coulomb. Neutron's mass is 1.67493 into 10 to power minus 27 kg and it is neutral, so its charge is 0. You may notice that heaviest is neutron. Neutron is slightly heavier than proton and lightest is electron. Other subatomic particles are positron, antiproton, neutrino, meson, etc. Now we will see atomic number and atomic mass. Atomic number first. The number of protons present in the nucleus is known as atomic number of the element. It is represented by capital Z. It is also known as nuclear charge. So Z is equal to number of protons. How to calculate the number of electrons? For neutral atom, number of electrons is equal to number of protons is equal to capital Z. And for charged atom, number of electrons is equal to Z minus charge on atom. We will see couple of numericals based on it. Atomic mass or mass number. The sum of number of protons and neutrons is known as atomic mass of the element. It is represented by capital A. It is also known as number of nucleons, as protons and neutrons are present in nucleus. An atom of an element is represented by either this way or this way, where X represents chemical symbol of the element, Z is its atomic number and A is its atomic mass. For example, neutral atom will be written like 6C12, 8O16. Charged atom will be written like 11Na plus, 13Al3 plus or plus plus plus, 9F minus. Let us see this question. If the number of protons in A2 minus is 14, then find the number of electrons in A2 minus and A2 plus. We know that number of protons is equal to Z. So Z is given as 14. We have to calculate the number of electrons in charged atoms. So number of electrons in A2 minus will be equal to Z minus charge on atom, that is minus 2. Z is given as 14, so 14 minus minus 2. Minus into minus is equal to plus, so it will be 14 plus 2 and that is equal to 16. Similarly, number of electrons in A2 plus will be equal to Z minus charge on atom, that will be plus 2. Z is 14, so 14 minus 2 will be equal to 12. There is a quicker method. Suppose A is not charged atom, this is neutral atom. So number of protons will be equal to number of electrons, means 14 electrons. But A2 minus is negatively charged and it is having 2 surplus electrons. So we will add 2 in 14. So 14 plus 2 means 16. In A2 minus, number of electrons is equal to 14 plus 2, 16. Similarly, in A2 plus, there is a shortage of 2 electrons, means 14 minus 2, that is equal to 12 electrons. See, the result is same. Second question, an element X with mass number 81 contains 31.7% more neutrons as compared to protons. Find the chemical symbol for X. It is given as mass number A is equal to 81. Suppose number of protons are X. Then number of neutrons will be equal to X plus 31.7%. means 31.7 upon 100 times x. So take x as common, so it will be 1 plus 31.7 upon 100, and that will come out to be 1.317x. So when you add number of protons and neutrons, it will give us mass number. So A is equal to P plus N, means x plus 1.317x. So A is 81. So 81 will be equal to 2.317x. When you calculate x, x will be approximately 35. Precisely, it will be 34.9. And what is x? Number of protons. And number of protons is nothing but atomic number. So Z is equal to 35, approximately equal to 35. And that is element bromine. So X is bromine, Br. Now we will see isotopes, isobars and isoelectronic. First, isotopes. Atoms of same element which have the same atomic number but different atomic mass are called isotopes. Example, hydrogen has 3 isotopes, 1H1, 1H2 and 1H3. Notice Z is same but A is different. Similarly, carbon has 3 isotopes, 6C12, 6C13 and 6C14. Oxygen has 3 isotopes, A216, A217 and A218. Isobars. Elements that have the same number of nucleons are called isobars, means they have the same atomic mass. For example, 16S40, 17Cl40, 18Ar40, 19K40, 20Ca40. So you notice here they are different elements having the same mass number. So they are isobars. Isoelectronic. Atoms, molecules or ions having the same number of electrons are called isoelectronic. For example, Na plus, Mg2 plus, Al3 plus, O2 minus, F minus. So let us calculate the number of electrons in them. So atomic number of sodium is 11. So number of electrons will be 11 minus 1, means 10. Atomic number of magnesium is 12. So number of electrons it will have 12 minus 2, that is 10. Atomic number of aluminium is 13. So number of electrons it will have 13 minus 3, means 10. Atomic number of oxygen is 8. It has 2 surplus electrons, means 8 plus 2, 10 electrons. Atomic number of fluorine is 9. It has 1 surplus electron, means 9 plus 1 is 10. So you see all have 10 electrons. So they all are isoelectronic. Isotones are isoneutronic. Atoms of different elements having same number of neutrons are called isotones are isoneutronic. You know that A is equal to P plus N, means number of protons plus number of neutrons, and Z is equal to P. So the difference of A and Z will give number of neutrons. See in this example, 6C13 and 7N14. Difference is 13 minus 6 is equal to 7 and 14 minus 7 is equal to 7. So they are isoneutronic. Similarly, 14Si30, 15P31 and 16S32. See the difference of A and P is 13 minus 14 means 16. 31 minus 15 means 16. 32 minus 16 is equal to 16. So they are isoneutronic. Isodiaphers. Atoms of different elements which have the same difference between the number of neutrons and the number of protons. That is, n minus p or p minus n should be same. For example, 7n15 and 9f19. So let us calculate the number of protons and number of neutrons. So number of protons it has is 7. So P is 7. Number of neutrons can be calculated from here. So difference of A and Z. So difference of A and Z is 15 minus 7. That is 8. So number of neutrons it has is 8. In this case, number of protons is equal to 9 and number of neutrons is difference between these. So 19 minus 9, that is 10. Now calculate difference between P and N, that is 8 minus 7, 1, and in this case 10 minus 9, that is 1. So they are isodiaphers. Similarly, 5B11 and 6C13. So number of protons here is 5. Number of neutrons is difference between 11 and 5, that is 6. And in this case, number of protons is 6 and number of neutrons is difference between 13 and 6, that is 7. Now calculate P minus N or N minus P. So that is 6 minus 5, that is 1, and in this case 7 minus 6, that is 1. So they are isodiaphers. Isosters, molecules which have the same number of atoms and electrons are called isosters. For example, CO2 and N2O. We will verify number of atoms first. CO2 has 3 atoms, 1 atom of carbon and 2 atoms of oxygen. N2O has 3 atoms, 2 atoms of nitrogen and 1 atom of oxygen. So they have same number of atoms. Now let us calculate the number of electrons. Atomic numbers of these elements are written here. So number of electrons in CO2 means 6 into 1 plus 8 into 2 means 6 plus 16, that is 22. Number of electrons in N2O will be, atomic number of nitrogen is 7. So 7 into 2 plus 8 into 1. So it will be 14 plus 8 means 22. So they have same number of electrons as well. So CO2 and N2O will be called as isosters. Similarly, CaO and KF are isosters. So let us see number of atoms first. CaO has 2 atoms, 1 atom of calcium and 1 atom of oxygen. KF has 2 atoms, 1 atom of potassium and 1 atom of fluorine. Number of electrons in CaO, Ca has 20 electrons and oxygen has 8 electrons. So 20 into 1 plus 8 into 1, that is 28. In KF, atomic number of K is 19. So 19 into 1 plus atomic number of fluorine is 9. 9 into 1. So it will be 19 plus 9, that is 28. So they have same number of electrons as well. So CaO and KF are isosters. Now let us see the mole concept. Atoms and molecules are extremely small in size. Their numbers in even a small amount of substance is very, very large. To handle such large numbers, a unit of convenient magnitude was required. In SI, mole was introduced as the 7th base quantity for the amount of a substance. 1 mole contains exactly 6.02214076 into 10 to power 23 elementary entities. An elementary entity may be an atom, a molecule, an ion, an electron, any other particle or a specified group of particles. 1 mole of a substance always contains the same number of entities. 1 mole is a collection of 6.023 into 10 to power 23 entities. This statement is important, you need to keep in mind. Also, these statements are important. 1 mole of an atom is also known as 1 gram atom. 1 mole of ions is also known as 1 gram ion. And 1 mole of molecules is also known as 1 gram molecule. Now let us see how to calculate number of moles. If number of any entity is given, then number of moles is equal to number of entity upon Na. Na is Avogadro constant. Its value is 6.023 into 10 to power 23 per mole. If mass of an entity is given, suppose mass of atoms is given, then number of moles is equal to mass of entity upon atomic mass. If mass of molecules is given, then number of moles is equal to mass of entity upon molecular mass. In case of gases, number of moles is equal to PV upon RT, where R is 0.0821 liter atmospheric per mole per Kelvin. 1 mole of any gas at STP occupies 22.4 liter volume or space. Now let us see relative atomic mass. Relative atomic mass of an element was first defined with respect to one hydrogen atom then with respect to one oxygen atom, and finally with respect to one carbon-12 atom. So relative atomic mass of an element with respect to one hydrogen atom is equal to mass of one atom of an element divided by mass of one hydrogen atom. And relative atomic mass of an element with respect to one oxygen atom is equal to mass of one atom of an element divided by 1 by 16 of mass of one oxygen atom. And relative atomic mass of an element with respect to one carbon-12 atom is equal to mass of one atom of an element divided by 1 by 12 of mass of one carbon-12 atom. Unit of relative atomic mass is AMU or U. AMU stands for atomic mass unit and U stands for unified mass. Now let us see gram atomic mass and gram molecular mass. First, gram atomic mass. The atomic mass of any element expressed in gram is called its gram atomic mass. It is also defined as mass of 6.023 into 10 to power 23 atoms. For example, gram atomic mass of magnesium is 24.305 U. So mass of one atom of magnesium will be equal to 24.305 divided by Avogadro constant, means 6.023 into 10 to power 23. So the result will be 4.035 into 10 to power minus 23 gram. It means mass of one atom of magnesium will be 4.035 into 10 to power minus 23 gram. Gram molecular mass. The molecular mass of an element expressed in gram is called its gram molecular mass. It is also defined as mass of 6.023 into 10 to power 23 molecules. For example, gram molecular mass of oxygen is 32 U. So mass of one molecule of oxygen is equal to 32 upon 6.023 into 10 to power 23. It is equal to 5.313 into 10 to power minus 23 gram. It means mass of one molecule of oxygen is equal to 5.313 into 10 to power minus 23 gram. Percentage composition and molecular formula. We will see two terms, average atomic mass and mean molar mass. Average atomic mass is also known as mean atomic mass. The weighted average of the atomic mass of all isotopes is called average atomic mass or mean atomic mass. So formula is A average is equal to A1x1 plus A2x2 plus A3x3 up to ANxn divided by 100, where A1, A2, A3 up to AN are atomic masses of the isotopes and x1, x2, x3 up to xn are mole percentage of isotopes. We will see numericals based on it. Second one is molecular mass or mean molar mass. Mean molar mass of the compound is given by the formula N1M1 plus N2M2 plus and so on up to NNMN upon N1 plus N2 plus N3 up to Nn, where M1, M2, M3 up to Mn are molar masses of the elements and N1, N2, N3 up to Nn are number of moles. Next we will see some numericals based on these formulas. Now let us see some questions. First question, calculate the sum of the number of electrons, protons and neutrons in 16 gram of A216. First we will calculate the number of moles. Number of moles is given as given mass of the substance upon atomic mass of the substance. Given mass of the substance is 16 gram and atomic mass of the substance is 16. So 16 upon 16, that is number of moles is 1. Number of electrons is equal to number of moles into Avogadro constant into number of electrons. Number of electrons here are 8. So it will be multiplied by 8. Number of protons is equal to number of moles into Avogadro constant into number of protons. Number of protons are 8. And number of neutrons is equal to number of moles into Avogadro constant into number of neutrons. 16 minus 8 means 8. So total will be sum of all three. So that will be equal to 8 plus 8 plus 8 means 24 into Avogadro constant. So that will be equal to 24 into 6.023 into 10 to power 23. And that will come out to be 1.44552 into 10 to power 25. Second question, the group having isoelectronic species is. These are the options given. We have to find out in which option all have same number of electrons. I have written their atomic numbers here. So let us start. In option A, O minus will have 8 plus 1 means 9 electrons. F minus will have 9 plus 1 means 10 electrons. Since they have different number of electrons, so this option is wrong. Let us see option D. O2 minus means 8 plus 2 means 10 electrons. F minus will have 9 plus 1 means 10 electrons. Na plus will have 11 minus 1 means 10 electrons. Mg2 plus will have 12 minus 2 means 10 electrons. So this option is correct. If there are more than one correct options, then you need to investigate further. Otherwise, you may stop here. Third question, the amount of oxygen in 3.6 moles of water is, these are the options given. First, we need to calculate the mass of 1 mole of water. So let us calculate. And that will be equal to 2 into atomic mass of hydrogen, that is 1, plus 1 into atomic mass of oxygen, that is 16. And that is equal to 2 plus 16 means 18 gram. Out of 18 gram, 16 gram is oxygen. Means in 1 mole of water, there is 16 gram of oxygen. So in 3.6 moles of water, how much oxygen? So let us write, in 1 mole of water, there is 16 gram of oxygen. So in 3.6 moles of water, how much oxygen? That will be 3.6 into 16 gram. So that will come out to be 16 6 are 96. 9 carry over. 16 3 are 48 plus 9. That is 57. So in 3.6 moles of water, there is 57.6 gram of oxygen. So let us see which option is correct. Option D is correct. Fourth question, given that the abundance of the isotopes 54Fe, 56Fe, 57Fe are 5%, 90% and 5% respectively, the atomic mass of the iron is. These are the options given. To calculate the average atomic mass of iron, we need to multiply their atomic mass with abundance. So it will be 54 into 5 by 100 plus 56 into 90 by 100 plus 57 into 5 by 100. And the answer will come out to be 55.95 U. So the correct option is option B. Fifth question, hydrogen has 3 isotopes A, B and C. If the number of neutrons in A, B and C respectively are X, Y and Z, the sum of X, Y and Z is. These are the options given. We know that hydrogen has 3 isotopes, 1H1, 1H2 and 1H3. We need to calculate the number of neutrons in them and then add them. Number of neutrons can be calculated by A minus Z. So in 1H1, number of neutrons will be 1 minus 1 means 0 plus. In 1H2, number of neutrons will be 2 minus 1 means 1. In 1H3, number of neutrons will be 3 minus 1 means 2. So the summation will be 3 and the correct option will be B. Sixth question, the average molar mass of the chlorine is 35.5 gram per mole. The ratio of 35Cl to 37Cl in naturally occurring chlorine is close to. These are the options given. Suppose there are N1 moles of 35Cl and N2 moles of 37Cl. Then average molar mass will be given by 35.5 is equal to N1 moles of 35 means N1 into 35 plus N2 moles of 37Cl means N2 into 37 divided by N1 plus N2. Now cross multiply, you will get 35.5 N1 plus N2 is equal to 35 N1 plus 37 N2. Now 35.5 N1 minus 35 N1 will be equal to 0.5 N1 is equal to 37 N2 minus 35.5 N2 will be equal to 1.5 N2. So N1 by N2 will be equal to 1.5 upon 0.5 and that will be equal to 3:1. So the correct option is option D. Last question. Complete combustion of 1.80 gram of an oxygen containing compound CxHyOZ gave 2.64 gram of CO2 and 1.08 gram of H2O. The percent of oxygen in the organic compound is. These are the options given. So the chemical reaction will be something like this. CxHyOZ plus O2 makes CO2 plus H2O. We will try to balance hydrogen and carbon. On the right side, there are two hydrogen atoms. On the left side, there are Y hydrogen atoms. So on the right side, we will multiply by Y and on the left side by 2. So hydrogen atoms on both the sides will be 2 into Y means 2Y. On the right side, there is one carbon atom and on the left side, there are 2x carbon atoms. So on the right side, we have to multiply by 2x here. So on the both sides, there are 2x carbon atoms. Oxygen atoms are not balanced. We will start our calculation from here. Mass of CO2 will be 44. 12 plus 16 into 2. So 2x multiplied by 44 is 2.64 which is given in the question. So x is equal to 2.64 upon 88. Similarly, mass of water is 18. 2 into 1 plus 16. 18 into y is 1.08 gram which is given in the question. So y is 1.08 upon 18. On the left hand side, mass of this is given as 1.8 gram means 2 times of mass of this. Mass of this can be calculated as x into 12 plus y into 1 plus z into 16 and that total is 1.8. So z can be calculated by substituting the values of x and y from here. Z will come out to be 0.03. Now mass of this whole is 1.8. So mass of this is 1.8 divided by 2 means 0.9 gram. So out of 0.9 gram, mass of oxygen is 16 into Z means 16 into 0.03 that is 0.48 gram. So out of 0.9 gram of CxHyOZ, oxygen is 0.48 gram. So out of 100 how much? It will come out to be 53.33. So option C is correct. In the next video, we will talk about empirical and molecular formula and gravimetric analysis. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.